9 questions were asked in the JEE main exam in the January 2024 session. That is, from the 10 question papers of the January 2024 session, 9 questions were asked from the section permutations and combinations, out of which 4 questions were numeric value questions, which we have already discussed in the earlier video. Now we take up the remaining 5 multiple choice questions from the section permutations and combinations that have appeared in the January 2024 session now. We take up the first question. This question has appeared in the JEE main examination held on 27th January 2024 in the second shift. The given question is, let alpha is equal to factorial of 4 factorial by 4 factorial to the power of 3 factorial and beta is equal to factorial of 5 factorial by 5 factorial to the power of 4 factorial. Then we are given 4 options. The options say which of these alpha beta belongs to natural numbers. So 4 options are given, and you have to find out which of these alpha beta are natural numbers. Agreed. Let's now discuss the solution of the problem in detail. We are given alpha is equal to factorial of 4 factorial by 4 factorial to the power of 3 factorial. So 4 factorial we have written as 24, right? 24 factorial by 4 factorial to the power of 3 factorial we have written as 6. Now, we recall a result what we have studied in our classes. The result says the number of ways in which mn distinct objects can be divided equally into m groups, each group containing n objects, is mn factorial by n factorial to the power of m multiplied by 1 by m factorial. Yeah, you have to consider. So, that 1 by m factorial also you have to consider. Right, this is the one. Now, in our case, 24, we see it as 6 into 4. That means 24 distinct objects can be equally divided into 6 groups, each containing 4 objects. Then this formula will be a natural number. So let gamma is equal to the number of ways these 24 distinct objects can be divided equally into 6 groups, each group containing 4 objects. That means in the above formula, we have to take m is equal to 6, m is equal to 6 and n is equal to 4. Then you will get 24 factorial by 4 factorial to the power of 6 into 1 by 6 factorial. What is this? This is the number. It's a natural number. So gamma is a natural number. So this is equal to gamma is a natural number. But what we want is alpha. Alpha is what? Alpha is 24 factorial by 4 factorial to the power of 6. What will be this one? Now cross multiply. 6 factorial comes to gamma side and multiply on multiplication gamma into 6 factorial. So alpha will be gamma into 6 factorial, and thereby gamma is a number, is a number of ways, therefore is a natural number, multiplied by 6 factorial is a natural number. So the product is a natural number, therefore alpha belongs to n. In a similar argument, we'll also show beta also belongs to n. That is how we will do. So given beta is equal to 5 factorial of 5 factorial by 5 factorial to the power of 4 factorial. 5 factorial is 120. 120 factorial by 5 factorial to the power of 4 factorial is 24. Right. What I can see is 5 into 24, 120. So 5 into 5, m is 5 into this n is 24, I think. So what we say, let delta, the number of ways in which 120 distinct objects can be divided into 24 groups, that is m is 24, and each group containing 5 objects, that means n is 5, that will be equal to mn factorial, that is 120 factorial by 5 factorial to the power of 24 multiplied by 1 by 24 factorial. Yes. In the above formula, m is 24, n is 5. You have to substitute and you get this one. What is this? This is a natural number. So delta is a natural number. So this is delta. Delta is a natural number. But what we want is beta. Beta is this portion only. So the beta will be delta times 24 factorial. That will be, delta is a natural number, 24 factorial is a natural number, the product is a natural number, therefore beta belongs to n. Therefore, both alpha and beta belongs to n. And where is this option? The option is, this appears against option 2. Therefore, the answer to this question is option 2. So that is the detailed discussion of the given question. I am sure that you have understood the solution of this problem. We move to the next question. Question number 2. This question has appeared in the JEE main examination held on 29th January 2024 in the second shift. The given question is the number of ways of arranging 8 identical books. You have to understand this word identical books, indistinguishable, into 4 identical shelves. So it is also indistinguishable 4 shelves. 4 shelves. 8 identical books, 4 identical shelves. The number of ways of arranging 8 identical books into 4 identical shelves, where any number of shelves may remain empty. That means any number of, out of these 4 shelves, any number of shelves may remain empty. It can be, no books will be in it. Then now we are given 4 options and we have to find the number of ways of arranging according to this question. So let's now discuss the solution of the problem in detail. We have brought you a tabular form, and what we have, 8 identical books and 4 identical shelves. 4 identical shelves. So case 1. So first case is number of empty shelves, and shelf 1 in which number of books, how many? Shelf 2, how many books? Shelf 3, how many books? Shelf 4, how many books? And at the end, the number of ways of doing this one. The first case is the number of empty shelves is 3. So 3 shelves are empty. So all the 8 books we put in shelf 1. In how many ways you can do it? In only one way. That is, put 8 here, zeros. And now one may say, sir, 0, 8, 0, 0 can also be there. But these are indistinguishable. Therefore, 8, it amounts to 3 zeros and 1 8. So, only in one way. Second case, 2 shelves are empty. So, this is shelf 3, shelf 4, we make it 0, 0. Then, how do I put here 7 and here 1. So, 7, 1, 0, 0. Again, 0, 0. I'll put 6, 2. So, 6, 2, 0, 0. I'll put 0, 0. And I'll put here 5, 3. 5, 3. And one may say, sir, 3, 5, 0, 0, 0. Is same as this one because these are indistinguishable. Therefore, and the next one is 4, 4, 0, 0. Now one may say, sir, 1 less than 4, that is 3, and increase 4 by 1, 5. So 3500 is also will be there. No. So 3500 is same as 5300 because these are indistinguishable shelves. So the number of ways, these are the only number of ways. So the number of ways is 4. Agreed. Case 3. So we make empty shelves 1. Only 1 is empty shell. The last one, let us say 0. So if you put the last shelf 0, one way is 6, 1, 1, 0, 0. Only one shelf you have to put 0. That's empty. So 0 here. So what I can do? 5, 2, 1, 0. Yes. The next what I will do? 4, 3, 1, 0. Yes. What is next? 3, 4, 2, 2, 0. Yes, this is also a combination with the 4. So the last one is 3, 3, 2, 0. So these are the combinations. You have to understand. So the number is 5. Now, no shelf is empty. In every shelf, some number of books will be there. So, fourth case, 0 empty shelves. So, what's that I'll put? So, the last one, let us say I put 1 and I put a 1 here. Then I put a 1 here. Then it will be what? 5, 1, 1, 1. Then what do I do? Next, 4, 2, 1, 1. Next, 3, 3, 1, 1. Yes. What will be next? So I'll make it a 2 here, a 2 here, 2 here, 2, 1. So 2, 3, 2, 1. At the end, I'll make this also 2. So all are 2. So these are the ways. You have to first understand the books are identical, indistinguishable. Shelves are identical, indistinguishable shelves. And any number of shelves can be empty. These are the conditions what we have. In the last case, case 4, we have 5. So the total number of ways of arranging these 8 identical shelves in 8 identical books in 4 identical shelves with the given condition is 1 plus 4 plus 5 plus 5, that is 15. Let's look at our options. Our answer 15 appears against option 4. Therefore, the answer to this question is option 4. And that is the detailed discussion of the solution of the problem. And I am sure that you have understood the solution of this problem. And we move to the next question. Question number 3. This question has appeared in the JEE main exam held on 31st January 2024 in the second shift. The given question is the number of ways in which 21 identical apples can be distributed among 3 children such that each child gets at least 2 apples is. The number of ways is given 4 options. So then we have to find out the number of ways of distributing 21 identical apples among 3 children such that each child gets at least 2 apples. It is a very easy question and it will not take much time. So let's now discuss the solution of the problem in detail. We have 21 identical apples and 3 children. Right. Condition: to distribute in such a way, the condition, each child gets at least 2 apples. So what's that you do? You give away 2 apples to every child. So 2 apples to the first child, 2 apples second, 2 apples to third. So give away. So thus we have distributed 2 into 3, 6 apples. So we have in total 21, we have already distributed 6. The remaining is 15. So then we are left with 15 apples. Now, what do you do with these 15 apples? You distribute among these three children, and some child may not get any one. Some child may get 0 apples. Some child are children, one or two child may not get any apples at all. So let's recall. So that means the required number of ways is the number of ways of distributing 15 identical apples among 3 children. We have already given 2 apples to each. So some may not get any, one may not get any, or 2 of them may not get any. It is possible. So the number of ways for that, you have a ready-made formula for that. The number of ways of distributing n identical objects, here 21 identical apples, and into R groups into 3 children. If empty groups are allowed, that means now one may say 1 or 2 may not get any. So empty groups are allowed. So empty means no. Some of the groups may not get any object. Here any apple. So some child or children may not get any apple. So that will be the n plus r minus 1, c r minus 1. N is 21, r is 3 here. So the answer for that is 15 plus 3 minus 1, c 3 minus 1. That is 17C2. That is 17 into 16 by 2 factorial. That is 17 into 8. When multiplication, we get 136. Let's look at our options. 136 appears against option 2. Therefore, the answer to this question is option 2. So that is the detailed discussion of the solution of the problem. I am sure that you have understood the solution of this one, and it is a very simple and straightforward question. Let's now move to the next question, question number 4. That is, it has appeared in the JEE main exam held on 31st January 2024 in the second shift. The given question is, if for some m and n belongs to set of natural numbers, 6cm plus 2 times 6cm plus 1 plus 6cm plus 2 is greater than 8c3 and n minus 1 p3 is to n p4 is equal to 1:8, then n pm plus 1 plus n plus 1 cm is equal to, we are given 4 options. It's a very simple question. Again, a simple question. So it tests only your knowledge, some of the formulae. Do you know, say the question tests you some of the formulae that you must know, for permutations and combinations. So let's move to the discussion. We now discuss the solution of the problem in detail. Agreed. We are given 6cm plus 2 times 6cm plus 1 plus 6cm plus 2 is greater than 8c3 for some m and n natural numbers. Right. This 2 times 6cm plus 1 we separately write. That is 6cm plus 6cm plus 1 plus 6cm plus 1 plus 6cm plus 2 greater than 8c3. So we have written this way. So the red one, first of all, take that 6cm plus 6cm plus 1. It is 7cm plus 1. And this is 6cm plus 1 plus 6cm plus 2 is 7c m plus 2. Why? We use this identity. What is this identity? This is the identity. NCR minus 1 plus NCR is equal to n plus 1 CR. This is Pascal's identity. Yes, this is the Pascal's identity. Now, so apply here 6Cm plus 6Cm plus 2 is 7Cm plus 1, and here it is 7Cm plus 2 is greater than 8C3. Now again apply this Pascal's identity. 7Cm plus 1 plus 7Cm plus 2 is 8Cm plus 2. So 8Cm plus 2 is greater than 8C3. 8C3. So it is greater than. So then what could be the value of m? For what value of m? 8Cm plus 2 is greater than 8C3. That's the question. Make an observation. So here we make an observation. 8C0 is equal to 8C8 in brackets. They are equal. And that is less than. This is 1. And less than 8C1 is equal to 8C7. This is 8. So 1 less than 8. Less than 8C2 is equal to 8C6. That is 8 into 7 by 2 factorial. Is less than 8C3 is equal to 8C5. Is less than 8C4. And we know that 8C4 is having the largest value when you take the binomial coefficients 8C0, 8C2, 8C0, 8C1, 8C2, etc., 8C8. Then if you see, the largest value will be 8C4, and the next largest will be the next one. This side is 8C3 or 8C5. So that means 8Cm plus 2 is greater than 8C3. This one means what could be m plus 2? M plus 2 should be 4. So this implies m plus 2 is equal to 4. This implies m is equal to 2. So m value we got. To get the n value, we take this ratio. N minus 1 P3 is to n P4 is equal to 1 is to 8. So n minus 1 P3 is n minus 1 into n minus 2 into n minus 3 by n P4 is n into n minus 1 into n minus 2 into n minus 3 is equal to 1 by 8. Now cancellation takes place. N minus 1 into n minus 2 into n minus 3 cancels both numerator and denominator. You are left with 1 by n is equal to 1 by 8. That implies n is equal to 8. Thus, the values of m and n we have obtained. M is equal to 2, n is equal to 8. Now we have to find out n Pm plus 1 plus n plus 1 Cm. Substitute. N is equal to 8, m is equal to 2 in this. Then it will be 8 Cp3 plus 9 C2. 8 P3 value is 8 into 7 into 6 plus 9 C2 value is 9 into 8 by 2 factorial. Multiply, add, you will get 336 plus 36, that is 372. Let's look at our options. The answer 372 appears against option 3. Therefore, the answer to this question is option 3. It is a simple and straightforward question. I am sure that you have understood the solution of this problem. We will now move to the last question, that is the fifth question. Fifth multiple choice question. And this question has appeared in JEE main exam held on 1st February 2024 in the first shift. The given question is, if n is the number of ways 5 different employees can sit into 4 indistinguishable offices, where any office may have any number of persons including 0. That means in these 4 indistinguishable offices, some office may not in that office known no employee may sit. That means in that one of the office may not have any employee sitting in that, and this can happen any number of persons including zero. Then n is equal to, we are given 4 options. Now let's now discuss the solution of the problem in detail. That is the given question to us. And what we have is the number of different employees is m is equal to 5. Different is distinct, indistinguishable, that way, right? Number of indistinguishable offices is 4. And what is to found now? N is the total number of ways to partition 5 into 4. So this 5 you have to partition into 4. So one of the parts can be 0. One or more parts can be 0. So the number of, so now we recall this formula. The number of permutations of m things of which p are identical. See, different employees means two employees means two employees sit in one office. So there will be 2 will be identical of one kind, Q are identical of second kind, R are identical of third kind, S are identical of fourth kind, is the number is given by m factorial by p factorial into q factorial into r factorial into s factorial, where p plus q plus r plus s is equal to m. And in this p, q, r, s, if any 2 or 3 or all repeats, then you have to divide by 1 by that number factorial also, because you have to, because the offices are indistinguishable. So we cannot talk about the permutations in that. So up to permutations you have to do that. So let's look into this table. So partition of m. M is what? 5. Partition of 5. Number of ways of doing that one. So partition is P, Q, R, S. And any number of this P, Q, R, S can be 0. Right? So number of ways, the formula is m factorial by p factorial, q factorial into r factorial into s factorial, all are in the denominator. The first way of partitioning 5 is 5, 0, 0. Yes. See, look at this. 5 different employees can sit into 4 indistinguishable offices, where any office may have any number of persons including 0. These are the offices. P, Q, R, S are offices. M is 5 people. So the answer will be 5 factorial by 5 factorial into 0 factorial into 0 factorial, 0 factorial, that is 5 factorial by 5 factorial, that is equal to 1. Next, 4, 1, 0, 0. Yes. This is 5 factorial by 4 factorial into 1 factorial, that is 5. Now, 3, 2, 0, 0. Here also, one may say, sir, I have 0, 0, 3, 2. 0, 0, 3, 2. These are indistinguishable. So whether it is here or there, it is one and the same. Right. Then the number of ways is 5 factorial by 3 factorial into 2 factorial, that is 10. And now 3, 1, 1, 0. Now write your answer. That is 3 factorial by 1 factorial multiplied by 1 by 2 factorial also you have to add, because these are the identical ones, and these are the employees. Employee A here, employee B here in one combination, and employee B here, employee A here. That means the permutation among the two people are also considered in this in this count, that is 5 factorial by 3 factorial into 1 factorial into 1 factorial. In that this permutation is also included. So up to that means 1 by 2 factorial you have to divide. So that will be 10. That will be 10. And the next one is 2, 2, 1, 0. Again, 2 is repeated. 2 is repeated. So that is 5 by 5 factorial by 2 factorial, 2 factorial into 1 factorial into 1 by 2 factorial. That's equal to 15. So the last one will be 2, 1, 1, 1. That is 5 factorial by 2 factorial into 1 factorial, 1 factorial, 1 factorial into 1 by 3 factorial, because 1, 1, 1 is repeated 3 times. So thus n, we have to count the total number of ways that is given to be n is equal to, add all these things, you will get 51. You will get 51. Let's look at our options. Our answer 51 appears against option 4. Therefore, the answer to this question is option 4. And that is the detailed discussion of the solution of the 5 multiple choice questions from the section permutations combinations which have appeared in the January 2024 session of JEE main examination. I am sure that you have understood the solutions of these 5 multiple choice questions, and I wish you all the best. Thank you.